You what the equipment they have out there and how they go about their work. So with his presentation on DG testing and compliance of materials, Rick Hughes.
Thanks, Colin. Thank you, everybody. Thanks for coming. Thanks for the committee for organising it. It's a wonderful place to be. I think you all agree. It's good to be out again after 5 or 6 months of isolation, particularly to a place like this. I put together a little bit of a talk today. It was pretty hard to actually work out, how to pitch something from a broad cross-section of stuff that we do. We probably classify ourselves as a materials characterization laboratory. We spread across a very, very wide, cross-section of businesses, from occupational health and hygiene. We work with hospitals directly doing biopsy analysis. We've worked with lungs. I've actually held a lung in my hand and dried it and calculated the number of asbestos fibres per gram of lung tissue, which aided in a legal case that was, unfolding over in the East Coast. We work from go to woe. One day we're working with ice cream. I don't know if you knew, but if you don't grind the chocolate fine enough, if it's greater than 20 microns, there's no taste. If it's finer than 20 microns, it tastes bitter. So we go from go to woe, because we'll be doing ice cream one day and we'll be doing fecal macular bacteria the next day. So it is a really, really broad cross-section. And at the moment, we've got a bit of a fun project on with one of the major vacuum cleaner suppliers in Australia, worldwide. And they've got 15 influencers from Australia and New Zealand. I only just learnt what an influencer was the other day, but apparently they're people on social media that get paid obscene amounts of money to spruik products, and they've been asked by this vacuum cleaner company to go and clean aspects of their houses, floors, mattresses, shelving, you name it, and they've sent everything to us, and we've done bacteria count, colony forming units, as well as dust mites, dander, you name it. And they're absolutely disgusted with the results. Nobody wants to put out the fact that they're getting 1,000 dust mites per gram from their own house. So I don't know whether it's going to come of any value to the vacuum cleaner company. But some of the big changes that have happened in one of our spaces, which is the DG testing space, was the REACH legislation adoption in 2006. So the registration, evaluation, authorisation and restriction of chemicals. That's the overarching one. The REACH now includes the GHS. And the GHS, Globally Harmonised System of Classification, basically says, we don't care what your ore is, what you're telling us is 99%. We want to know what the 1% is, and is it going to kill anybody? The level of detail and attention being paid to this now has dramatically risen with insurance claims. In the last 30 years, 23 ships have gone down with liquefaction of their cargo. So when a cargo is taken out onto a port like this and loaded, ready for transportation, the company has a moisture management plan to make sure that the product, when it's being handled, doesn't emit dust and cause nuisance to nearby towns. As you've probably seen up at Port Hedland, pretty much everything there is red. So they have to have a moisture management plan which keeps the product above its dust extinction moisture. So that's an Australian standard that was developed by Rio Tinto for coal, and everyone's wondering why their products don't perform very well whenever it's rolled out to copper sulfides, nickel sulfides that are pretty much oxidizing during the test and producing anomalous results. But the thing with the moisture management plan is that if they get the moisture wrong, if there's rain, if the moisture's too high, the cargo's liable to liquefaction. And I think the last ship that went down, 2017, went down in 14 minutes. So it was in heavy seas, and just the routine pounding of the ship's hull, the moisture content was high enough that the water actually produced hydraulic back pressure, and the cargo liquefied and tilted the ship, and it went over and down in 14 minutes. I think all hands on deck were lost that time. But needless to say, within about a month, we had Lloyd's of London and Brooks Bell knocking on our door saying, It wasn't us that did the TML, but they wanted to make sure that we were doing it correctly. So since then, we've gone through all the proficiency testing. We got NADA accredited. You name it, there's no stones left unturned. But it kind of showed the importance of, you know, a simple test, and it is literally a simple soil geomechanics test that can be done in a couple of hours, and the consequences of getting it wrong, which obviously this lab did, toppled a ship, and you know, not only the lives were lost, but obviously the ship and the cargo as well. So the DG space that we're in at the moment, we have been asked to do explosive materials, but apparently the Army don't like renting out their bunkers, so we've given that one up. Flammable liquids, we do that. Gases, we do evolution of gases, so if your product is going to be shipped, is it going to release anything in the hold of the ship and kill anyone who ends up going in the hold for any reason? The flammable solids is an interesting one. You know, if you ever wanted to blow things up whenever you were at high school, it's a good area to be in because you get to mix things with volatiles, set fire to them in a fume hood and watch them burn, photograph them and report. Oxidizing solids, again, we get involved in that. Toxics and infectious substances we don't tend to get much into. Radioactive materials we're trying to get into. It's a bit of a closed loop at the moment, with SGS being one of the major providers, having bought out Western Radiation Services. Corrosive materials is probably the biggest one where we found a bit of a footprint for ourselves. So it was the one I was going to talk to today, which probably comes on the back of some of the stuff that Katrina was doing, and also Peter Farina about the corrosion coupon testing. So this was brought out as part of the GHS legislation that was 2006 was it, I said? It's been around for a while now, but it was basically a standard that was already in existence, and it was just adopted, and everyone that was shipping copper sulfide, nickel sulfide, iron ore, you name it, anything that's going out of the ports here in Australia, they suddenly had to conform to this Class 8 corrosive to metals test, and there were two main classifications: the uniform corrosion of the test and the localized corrosion of the test. When we were testing samples initially, they were all failing, without exception, all failing, and nobody was prepared to ship because at the end of the day, Lloyd's wouldn't insure them if the ship left the port and their product had been classified as corrosive. So, needless to say, when it was, $70 billion worth of exports, everyone was pretty keen to try and get to the bottom of why this standard was making, the products, the ores and the concentrates fail. So we were doing a little bit of work in that space with other players beforehand, but this suddenly became quite a heated topic of conversation, and it ended up involving Curtin University as well. The coupons that went in for the testing were, according to the standard, just a carbon steel and an aluminium and an aircraft alloy. There's an exemption out now that only mandates the carbon steel. The three coupons are put in. One is above the airspace, one's half submerged, one's fully submerged, and the vessel is kept at 55 degrees C for 28 days. And at 28 days, you take them out and clean the coupons up and measure the mass loss and also the pitting depth. And there's two different standards that make them comply. So that's a typical suite of coupons that would come out after 28 days. As you can see, there's a fair bit of loss of material on the middle one. So the two different classifications under the UNDG are MHB and materials handling in bulk, and the UNDG classification itself. So they're slightly different depending on the material and how it's handled. But you're basically allowed for 28 days 33% mass loss on the MHB and 50% mass loss on the UNDG, which I can't quite work out, because if you were losing half of your ship over a 4-week period of shipping, that would be a significant loss of structural steel, I would have thought. Anyway, that's what we got to go with. So we would then take those coupons out and we would put them into our Solaris, and we would do a surface profile scan. So this is a very high resolution topographical laser scanner. So it's got a very high precision XY stage that can be ramped down to as low as 1 micron in XY. We've got a choice of light pens, laser pens, that can give us as low as 5 nanometers in the Z direction, or we can go to a different light pen and do curved surfaces where there's a much better depth of field. So it depends on the size of the sample. We can take anything from about half an hour up to 4 or 5 hours. You can ramp up several samples at the same time if they're small enough and leave it running overnight. It wasn't too good on power failures, this thing. We had to put a massive UPS on it to keep it going because some of the power interruptions that we were having meant that all of the data that it was collecting and being stored in RAM were being lost. So it was quite a frustrating instrument to work with. So there's a coupon image with the Solaris solar scan giving you the depth of corrosion, the surface loss, over that entire area. So the classification for the UNDG was 120 microns, so if there was any pits greater than 120 microns or more than a certain amount of mass loss, it was deemed to have failed, and the certificate went back to the shipper to say that the material was not safe to be shipped in that condition, and they had to do something about it. So we were getting a lot of feedback saying, you know, why they were wanting a lot of mixes made up. You know, we were adding lime to various samples to try and see if we could control the corrosion and everything. One of the things that we noticed in some coupons, there was so much surface loss that we were actually not able to have a reference point that, you know, at the end of the day, if there was nothing of the original surface left, how did you actually know how much loss had happened? And we were sending, the clients that were getting other tests done like this were sending them off to other labs, and samples like this were coming back as a pass. So there was a lot of mixed messages coming up depending on how people were ascertaining what a pit was. So everyone started arguing about what a pit was after that. So the cross-section of that coupon on the top left there, you can see the dotted line from top to bottom produce a profile curve on the top right graph. So you can very easily and quickly see you know, just what has happened, and you can you know, ascertain what the pit depth is. We were often taking those coupons and putting them into electron microscope and having a look and see if the pits were also still filled with corrosion product, which could then mean the pit was actually a lot deeper, but the surface scanner was basically just seeing the corrosion product on top. So it was a particularly useful technique, and it was giving, you know, relatively accurate numbers for them to work with. What we found at the end of the day was there was a big change depending on how the coupons were prepared. We followed the standard. The standard said 120 grit paper. We were actually doing it dry initially, and then we were told to try doing it wet and do it on 240 grit to try and change the surface roughness to see what was happening. We ended up testing different coupons of ship grade steel, AH32, to see if they provided a different results, and they did. They were actually a little bit better than the ISO steel. So again, it shows that a lot of the standards that are adopted that come in can have massive consequences for exporters, and those were unforeseen consequences at the time somebody picked a standard off the shelf and said, let's follow this. So the things that came through, you know, at the time in 2006 did upset, you know, quite a lot of different industries for different reasons. We ended up putting oxygen probes in because the information that we got back from the shippers was that once the ship leaves port, the hole's closed. Anything that's reacting in the hole, oxidizing, is going to consume the oxygen and effectively slow down the reaction rate. So we were able to prove that was the case, and the standard actually said that because it was originally designed as a liquid cell, it was to have an opening to the atmosphere with a reflux condenser. So there was actually a ready supply of oxygen for the whole 28 days. Once you ramp that off, close the cell up, close the test vessel up, it changed the corrosion rate. The 0.5 there was a bit of a funny one because some of the coupons were corroding so badly that we had no reference surface to work with, so we actually ended up having to work with some epoxies and other polymer 2-pack paints to try to get a shielded reference point so that at the end of the 28-day test we still had some original surface, and what we found worked best was pink nail varnish. And I got a good photo of us all doing our Rocky Horror Picture Show with it, but I wasn't allowed to put it up. So there was a big difference between the sandpaper used, and again, you know, that probably meant that the standard needed to, you know, be developed more and accommodate that. And we've actually been on the standards committee for the review of a couple of standards. We're trying to get onto this one. I don't know how successful that'll be. Sometimes the you know, standard reviews can be taking, you know, minimum of 6 to 8 years before you even get a technical committee together, before people will actually sit down, and then they like to argue about shall and could and everything else rather than the actual technical stuff. So the pit depth, you know, we tried to put forward, you know, the issues that we were having with actually understanding what the pit depth relative to the starting surface, and also getting a pre-surface scan if there were any defects from the rolling process. A lot of the coupons that we were analysing actually had defects in them, you know, as deep as 20 to 30 microns from the rolling process, so they could actually then turn into a corrosion pit during the test. So, you know, if you're going to fail something on a 120 micron pit, well, it was already 20 micron before the test started. So yeah, there's a whole range of things there that was brought out from some of the testing that we did. Probably the biggest thing was that the standard actually said that the moisture content was irrelevant, and there was a lot of talk between us and AMSA, which is the Maritime Safety Organisation, overly bureaucratic and never willing to make a decision. At the end of the day, they did actually say that all samples should be made up to 10%, but having said that, a lot of the samples that we're actually testing for the TML, if they're down at 7 or 8%, then, you know, if they're failing at 10%, it's a bit of a unfair test if it's never actually being shipped at that. And, you know, obviously excess water in there. A lot of the iron ore that we were testing had very, very high chloride content. A lot of the stockpiles are watered with brackish water. I don't know if they're actually watered for the moisture management plan with seawater, but there was certainly high chlorides in there. And I know also that some of the mines up north actually have started to excavate and shift benches that are actually at or below the water table. So if you've got a high salt content there, you're bringing your stockpile onto the wharf, and you're managing that with a moisture management plan, and then that goes into you know, any sort of test or any sort of hold. Those chlorides, as Peter was alluding to, they're your worst enemy, so they're already in your product at elevated you know, concentrations before you start. So we've actually been reducing them back to the TML. We've had to do the TML first and then actually do the corrosion test at the TML percentage, the transportable moisture limit. So we were actually asking the shippers what types of ships there were. Some ships keep the holes open partially, some fully close them. So now that's becoming part of the standardised processes to actually monitor oxygen content throughout the 28-day test. There is a little bit of a video here. I don't know. Oh yeah, there we go. So this is another coupon that somebody might recognise. So these are the kind of things that you can do with the Solarius. This is a low resolution scan. So that coupon's about 50 millimeters long. So you can look at the you know, surface roughness and get a whole heap of values about, you know, what's there in terms of corrosion, as well as cracking, as well as the formation of it. We've done lots of fun stuff. Coins were always a bit of a novelty value whenever we first got the machine up and running, as were sponges and other rough stuff that people couldn't really guess from this profile what it actually was. So anyone got any clues as to what that is? That's my friend Owen's toe. He dropped a paver on it and lost part of his toe and kept it and brought it in and ran it on the Solarius. I did leave it till a little while after dinner, lunch. So some of the other things we do is the optical imaging, SEM imaging. We do a lot of sizing and materials characterization. So some of the work from the coupons has gone in to do, multi-stage. There should have been other stuff on that. That might have been a different one. There was just some images of multi-stage corrosion artifacts on the surface of coupons where you were getting, two-step processes. There was a nice way to show elemental maps. I don't know if it's up there or not, is it? Did I have two on there? I thought I deleted the other one.
I can find it now.
Let's see.
I'll have to scoot through.
Yeah. I'll just see if I can get quickly to the end of this and just show you.
A couple of minutes.
Yep. Where's the...
Just press the down the bottom right.
Yep. You don't want to move. So that's part of a coupon surface, looking at some of the corrosion that we were able to see. I'm sure you've all seen electron images in backscatter, so the brightness is proportional to atomic number. So you can see where there's the lighter grey is the native steel, and then you've got the corrosion product in the different areas there, denoted by spectrums 1 and spectrums 3. So it's very handy to be able to go in and have a look. Some of the other stuff we're doing is elemental mapping, as Paul was mentioning earlier on. There's an etched microstructure there and an electron image on the top left, and it's a little bit hard to see, but you can see the carbon map there showing the carbide precipitates on the grain boundaries, and then the chromium map showing the chromium carbides at the grain boundary, and then there's a big inclusion here of niobium sulfide related to that. So some of the work that we do is varied. I don't claim to be a metallurgist, but it's always interesting when the guys come in and show these unusual samples, and we get to work with them. Phase mapping is looking at combinations of element X-rays coming in at the same time, so we actually get information about specific phases rather than just one element. So you can actually look and see what compounds are likely to be present based on the fact that there's certain concentrations of elements giving you a signal at one time versus another. So all very good.
Yeah.
Any questions?
Any questions for Rick? What about pink nail varnish or anything like that? Sounds very interesting. No pictures of the...
No.